In this video, we're going to take a look at a framework for API development in Python, and that framework is called Litestar. I have the documentation open here. It allows you to, as it says, effortlessly build performant APIs, and it's quite similar in a lot of ways to Fast API. You can see the syntax on the right hand side for declaring a very simple Litestar application. We import an object called Litestar and a decorator called get. We use that decorator to create a root in the application, and then we have an async function that returns some kind of response, and you can see the type hints here for the type of response being returned. So this framework is async-ready, and it uses Python types much like Fast API, and it has great integration with Pydantic and things like data classes. So this is a modern Python framework for API development. Let's dive in this video and see how to define some get and post endpoints. So what I'm going to do is go to the documentation for Litestar, and we're going to copy this installation command. Now we're not just going to install Litestar itself. Let me make the text bigger here. We're actually going to install Litestar standard, which includes some commonly used extras like 𝗬𝗍𝗀 and 𝗬𝗬𝗃 if we're using HTML templating. So let's copy this here, Litestar standard, and I'm going to open VS Code, and I have a virtual environment in Python, and I'm going to pip install the Litestar standard package, and that's going to bring down not only Litestar but also 𝗬𝗍𝗀 and 𝗬𝗬𝗃. Now while that's installing, what we're going to do at the top here is we're going to import from the Litestar package that Litestar object. Now if you've used Fast API, this is similar to the Fast API object that you instantiate in order to create an application. And we're also going to import a decorator, and that's the get decorator, which is going to allow us to hook up a get request to a particular path in our application. So let's just do this to the root path, and once we have that decorator, we need to write the function, and that can be an asynchronous function in Python. So we're going to call the function home, and it's going to return just a string, just a bit of text coming back from this API endpoint. And let's return some text, hello from Litestar. So here's a very basic function that we have. What we need to do now is instantiate this Litestar object and create an app object at the bottom here. So let's instantiate Litestar, and to that we pass a list containing all of the endpoints that we want to use. So we have one called home. Let's just pass that in, and we can then save this file, and I'm going to make the terminal bigger here, and we can run, because we've named this file app.py, we can actually run a command called Litestar run. And under the hood, that's going to use 𝗬𝗍𝗀 in order to start a server on port 8000. And what we're going to do is we're going to go to this page in the browser to see the response that we're getting back from this function. As you can see, it says hello from Litestar, and when we go to that page, you can see we get that message in the browser. So this is a very simple text response that we're getting from the API endpoint. And we can also return different data types here rather than a string. Let's say we wanted to return a dictionary where the keys are strings and the values are also strings. Now we're going to build an example using bands in a minute, so I'm going to return a dictionary, and let's just say the name of the band is the Kinks. If we save that, we now have a different return type, a dictionary, and when we go to the browser you can see we get the response. And in fact I need to restart the server with the reload flag. So what I'm going to do is run the Litestar run command, and we're going to pass the reload flag down to 𝗬𝗍𝗀 in order to detect when we make any changes, and then we can go back to the page, and this time we're getting what is actually a JSON response. And if we analyze the terminal, you can see that we also have something enabled here, and that's the Open API documentation. If we go to this path /schema, we can see that documentation for our API. So let's go to that path, and we get this API documentation, and that's for free. That's right out of the box when you use Litestar. Very easy to set up the documentation for each of these routes that you have in your API. We'll look a little bit more at the schema later in the video, but let's continue, and we're going to go back to VS Code. And what I'm going to do here, just above the handler function that we have, is I'm going to define a list of bands, and each element in that list is a Python dictionary containing 3 keys: the ID, the name of the band, and the genre of music for that band. So we have a list here containing 4 bands. Now you can imagine in real life this data would be coming from a database, but in this case we're just going to use a list that we have in the application in order to demonstrate how to use Litestar. Now we're going to create 3 endpoints, one to list all of the bands that we have in the database. Another endpoint is going to retrieve one band by its ID, and you can see the ID field in each of those dictionaries. And finally, we're also going to create a new band from one of these endpoints, and that's going to be done with a post request. So let's start with the listing of all of the bands, what we're going to do is we're going to rename this endpoint, and I'm going to call it bands. And that is going to return, as you can see in this data structure, a list of dictionaries. So we're going to change what's returned here, the type hinting, and we're going to return a list of dictionary objects. And it's very simple to return the bands. Instead of hard coding that dictionary in the function, we're just going to return this variable that we have where we defined that list of dictionaries. So we're returning that, and we're going to change the name that's passed into our Litestar object, and we can save this, and we're going to go to the browser and test this out. So let's go back to the page that we had, and that was right at the root of the application. And this time when we refresh this page, we get back these bands. And I've loaded that on a different browser here on Mozilla Firefox, where I have some JSON extension, and you can see the JSON data coming back very clearly here. We can look at the raw data, but this extension allows us to view the data in a nicer format, and you can see we have each of the bands that we have in this list that we defined. We're returning all of those, and we have this type hinting going on as well. Now we can do more complex things with this typing. Rather than returning a list of dictionaries, we can actually define an object for each of the bands that we have in this application. So each band has 3 fields. We can encode that in a Python object, and what I'm going to do is install Pydantic for this example. So we can at the bottom run the pip install Pydantic command, and we're going to define a very simple Pydantic model for this data. So from Pydantic, what I'm going to do is import the base model class, and then just underneath this list of bands we're going to define a class called band that is going to inherit from that base model. So this is the class that's going to define the schema of a band in this application. We have an ID which is of the type integer. We have the band's name, that's just going to be a string, and we have the genre of music, which is also a string. And if you wanted to limit the genre to a predefined list, you could use something like an enum for that, or a literal type. But we're just going to set that to a string here, so we're going to allow any genre to be sent to this API. So that's our extremely simple Pydantic model. What we can do down here in the bands endpoint is we can change the return type. Rather than a list of dictionaries, we can return a list of these band objects. And we need to change what's being returned here, and we need to actually create a Pydantic model for each one of the dictionaries in this list. So what we're going to do, instead of returning bands like that, we are going to return a list comprehension where we take each band. So I'm going to call each band B, and we're going to get all of the keys and values from that dictionary, and that's for B in bands. So just to go over this in case I didn't explain that well, we are iterating over all of the bands that we have in this list of dictionaries above, and for each one of them we are creating that band Pydantic model. And we're doing that by unpacking the keys and the values and sending them to the model. That creates the model instance, and we have a list comprehension that's doing that for every single object in this list. So let's save this file, and we're going to test this out in a second. But just before we go on, of course you don't want to mix your models and your views or your API endpoints in the one file. You might want to separate things out into different files, and that makes things a lot more maintainable. But I'm just going to stick with the one file in this video. Let's now save all of this, and we're going to go back to the API, and I'm going to refresh this page, and we should see the same data coming back here. Now I have a problem here because I've stopped the server in order to install Pydantic. So let's run the Litestar run command again, and we can go back to the page and try this again, and we're still getting the same data, but now what we're doing is we're using this Pydantic model class, and we're converting all of the objects to these models. And this is not going to work if we have something that doesn't conform to the schema of this model. So for example, if we look at the bands here and this last one for the Wu-Tang Clan, if I change one of the keys to names and we save this and we go back to the browser and try and refresh this, we're going to get an error because what we have in these objects here, when we try and convert it to the Pydantic model, it does not conform to the schema of that model. And that's going to cause an error because of this statement here. The band is expecting a field called name, and instead we're passing something else. So let's change that back. Now let's define a new endpoint. We're going to fetch a band by its ID. So for example, if we went to the root with ID 1, we want to get back the details for the kinks. What we need to do in order to get a band by its ID is use the ID as a root parameter in the URL. So we have this URL here for the GET request. I'm going to copy that and we're going to paste that below. And what I'm going to do is I'm going to go to the documentation for Litestar, and this is how you define a root with a root parameter. We use the curly braces and we give the parameter a name and a type. So we're going to do that now in our application. But in fact, before I start that, let's give these API routes the name that conforms to the REST API structure. So we're getting a list of bands, we want that URL to be /bands, and below here I'm going to use /bands, and then we're going to use the curly braces, and we're defining a route here that we're going to call band ID, which is of type integer. We can then define the function that we're going to use for this API. So it's going to be an async function, and we'll just call that band, and it's going to take the band ID from the URL as a parameter here, and again that's of type integer, and this is not going to return a list, it's just going to return a single band from this endpoint. Now what we need to do is we need to try and find the band by the ID that's passed in the URL. So if we look at the list here, we have 4 IDs. We're going to search through this list and try and get the first element with that particular ID. So in order to do that, I'm going to use a function in Python. Let's create a variable called band, and we're going to use the next function. And you can see the signature of this function. It takes an iterator, and then optionally it takes a default value if nothing is found in that iterator. So if the iterator is exhausted and you don't want to return a stop iteration exception, or rather you don't want to raise that exception, instead of that you can define a default value. So let's start by defining our iterator here. And again, we're going to create a band and unpack the arguments for each band in our list of bands, but we're only going to do that conditionally. And that's if the band that we're looking at's ID is equal to the ID that's passed into this function. So we're using this next function, and this is our iterable here, and we try and find a band by the ID that's passed into that function. So that's the first argument to the next function. The second argument, if we don't find one, we want to just return none. So the default value, if we don't find something, will be none. And then in the function we can check if we have a band. So what I'm going to do actually is check if we don't have a band. So if band is none, what we can do is we can raise an HTTP exception here. Now I need to import this class from Litestar, so let's go to the top here, and from Litestar, and it's actually the litestar.exceptions module, we're going to import the HTTP exception. And what I'm also going to do while I'm at the top here is import the status codes from Litestar, and we're going to use these in the function below. So we're going to raise an HTTP exception, if we don't find a band, and we can pass some arguments to this exception. So the first one is going to be the status code, and I'm going to use that status codes module, and if we don't find something, we want to raise HTTP 404 not found. So these status codes, I think it's an enum behind the scenes, and it's going to encode all of the different response statuses that you might want to use in an HTTP response. And as well as the status code, we can also pass a message using the detail argument, and I'm going to use an f string for that, and I've copied too much here. Let's use an f string, and we're going to tell the client that no band has been found with the ID that was given. So this if statement will handle the case where we don't have a band, we've not found a valid band from that iterable. If we do find one, we can just return it, and that will be all we need to do from this function. So if we find a band, we've already converted it to a Pydantic model, and that's exactly what this function is expecting to return based on this type hinting. So we can save this function. So let's go back to the browser and we're going to test this out. We are on the list endpoint, which is now /bands, and we can see all of the bands that we have in that list. I'm going to add one of the IDs, and let's add ID 1 to this URL. So we've added ID 1, and this time when we send the request, we're actually getting back a 404 not found. So why is that happening? And this 404 not found, it's actually because I've not added our new endpoint here, the band endpoint, to this Litestar object at the bottom. So let's do that now and save the file. And if we go back to the page and we try this again, we're now getting back the details for the band with ID 1. And if we change that to ID 3, when we refresh that page with ID 3, we're getting back that particular band. So we now have a detail endpoint that's retrieving an individual band from that list by its ID. Now what we can do is we can actually move these endpoints into something called a controller class in Litestar. We have this functionality that works on, or rather it's related to that object, the band object. And sometimes you want to group these endpoints together so that it's easier to read and easier to share information. You can do that with a controller class in Litestar. Let's go back to the documentation for this. And on the right hand sidebar of this page, which I'll leave a link to below the video, we have a philosophy section. So let's go down here, and you can see some of the points for this framework. It's drawing inspiration from a TypeScript framework called Nest.js. The one below that is telling us that it allows function-based endpoints, but Litestar will seek to build on Python's powerful and versatile object-oriented programming. So it places these class-based controllers at its core. So we're going to change these endpoints in order to use a controller class. So let's go back to our page and we're going to import the controller class from Litestar at the top. So from Litestar, let's import the controller. And what I'm going to do just below these comments is I'm going to create a class that we're going to call band controller, because this is going to be related to the bands that we have in this application. That's going to inherit from the controller class. So we've created a subclass of that, and then we can define a common path for these operations. So we're going to say /bands, and that matches what we have here for the get endpoint. And also down here we have /bands and then the dynamic ID. We can still add that dynamic ID. This is just the base path for all of these endpoints. Now what I'm going to do is copy this code here for our get endpoint, and I'm going to paste that into the controller class here, and I need to fix the indentation. So we have the get endpoint, and we can actually remove this path because that is already defined as the root path for this controller. And the only other thing we need to do is, because we are now using a method on a Python class, we need to pass self as an argument here. So we've moved this band list endpoint into the controller class. Let's now do the same for the detail endpoint. So let's cut this out and we're going to paste that into the class, and I need to fix this indentation. Now we need to make a couple of changes to this endpoint. We don't need the root path because that's already defined above. We only need the dynamic part of this URL for the band ID. And just like before, we need to pass self in as the first parameter to this method because it's in a Python class. And then we can save the file, and what we are going to do at the bottom is we're going to fix what we're passing in here to the Litestar object. And we can just pass a reference to our controller class, and that is going to add all of the roots within that controller to the Litestar application. So with these changes, let's save the file, and we're going to go back to the API, and hopefully everything is still going to be working. So I'm on the list endpoint here, and I'm going to refresh this, and you can see we are still getting the same response. And if I add one of the IDs, let's say 2 for Aphex Twin, we've added that to the URL, and when we go to that endpoint, we're getting back the detailed response for that particular band. So this is all still working, but we've refactored the code to use a controller class in Litestar here. We're going to add one more endpoint, and that endpoint is going to allow us to create a new band and add it to our list here, and that's going to take a post request. So at the top, as well as importing get, we're now going to also import the post decorator from Litestar, and we're going to go to our controller class, which is here, and we're going to define a new root, and we're going to use the post decorator in order to do that. So that's the decorator. What we're going to do is we're going to define the body of this function, and let's call the function createBand. And that's going to take 2 arguments. Again, it's a Python method on a class, so it's going to take self as the first argument, and the second argument is going to be data, and this data is coming from the request body that's sent in the post request, and that's the data that we're going to use to create a new band and add it to our list, and that is going to be type hinted using that Pydantic band model that we created. So we're going to create that band, and we're going to return it as well after it's been successfully added to the list. So we're just adding it to this list here. Of course, in a real application, you would add it to some kind of database, but either way, you're going to return the created object typically after it's been added. Now what we're going to do is we're going to assume that the client is not sending the ID for the band. These IDs are typically determined, for example, by the database. If you have a sequence in the database, and that sequence might be auto-incrementing, for example. We don't have a database here, but what we're going to do is we're going to define a variable that I'm going to call nextID, and we're going to get the record from that bands list that has the maximum ID. So I'm going to use a key function here to the max built in Python, and that key is going to take each record in the list of dictionaries, and it's going to order those dictionaries by, let's say, the ID. So what this max call here is going to do is it's going to look at all of the bands, and it's going to try and find the maximum record based on this key function. Basically, the maximum record is going to be the band with the greatest ID, and then once we get that band, we can index in to actually get the raw value for that ID, and we're just going to add 1 to that to get the next ID that we're going to use. So when we run this function for the first time, it's going to look at this list up here, and it's going to find the maximum record, which is this one here with ID 4, and it's going to index in to get the value for it and add 1 to that. So the next record will have the ID of 5. So I hope that logic makes sense. Let's scroll down here, and the reason we're doing this, of course, is yep, we're assuming the client is not sending an ID. So what we're going to do with the data is we're going to take that data, which should be an instance of the band model, and we're going to set its ID equal to that next ID. So that will set the ID on the Pydantic model, and then we can take the bands Python list that we have, and we're going to call the append method. And then we're going to take our Pydantic model, which has a function called model dump, and this function here basically converts that Pydantic model to a Python dictionary. And that's what we want, because our list up here, it's not Pydantic models, we've just defined these as Python dictionaries, so that is going to convert the data that we have to a Python dictionary and then append that to this list. And the final thing we need to do is just return the data. Now, one thing I should have said, the reason we're calling this data, if we go to the Litestar documentation, as you can see there's a page here, I'll link this below the video, on the request body, and the body of an HTTP request that's typically sent in a post or a put request, that can be accessed through that special data parameter in your handler functions. So that's the reason that we've called this data here. That is going to give us access to the request body that's sent from the client in that post request. So let's now test this post endpoint out. In order to do that, I'm going to use an API client called 𝗬𝗵𝗽. I'll leave a link to the documentation for this below the video, and you can also download that onto your operating system. This is an API client. It allows you to design, debug and test APIs locally or in the cloud. We're going to use that, and I already have this downloaded here on a Windows machine. What I'm going to do is add an HTTP request, and we can define some details for that endpoint here in 𝗬𝗵𝗽. So the URL we're going to send this request to is 127.0.0.1, so that's basically localhost, and it's the /bands endpoint here. So we're going to send a request to /bands, but we want that to be a post request, so we're going to change the HTTP method type to post, and we're going to add a body to this call. So we're going to add a JSON body, and we can actually add the request body here using this syntax. So it's basically JSON data. We have an ID and a name of Black Sabbath here, and the genre for that band is metal. So what we can do is then send that request to our API, and you can see we're getting an error, could not connect to the server, and that's a mistake I've made. We didn't put the port number of 8000 in that URL. So let's try this again with the correct URL, and now we're getting an internal server error. So let's go back to VS Code. And actually what went wrong there for me was this function here, the data.modelDump function. So this model dump function is defined on Pydantic models, but I think this was added in Pydantic version 2. Before that we had a different function, the .dict function, to convert the model to a dictionary. So depending on what version of Pydantic you're using, make sure you use the correct function to convert that model to a dictionary. And if you want to upgrade Pydantic, you can stop the server, and the command that I used was pip install -u Pydantic, and that will upgrade to the latest version of that package. So once we've done that, let's start the server again, and we're going to go back to 𝗬𝗵𝗽, and we're going to send this request with the data for this band. So I'm going to send that post request, and this time we get back the same object. And we can test whether that object is in our list endpoint by going to this URL here, and you can see it at the bottom. This is the endpoint that's listing out all of the bands that we have in our backend, and that band Black Sabbath is appearing at the bottom. So that's been added to the list on the post request using that request body. Now, as I said earlier, this is working, but we don't want to be sending the ID in the post request. We want that to be allocated to the band, for example, by the database on the back end. So we're going to remove this ID from the post request, and we're going to try and send this again. And this time we're getting a validation error from Pydantic. And the error is telling us that this field, the ID field, is required, and we are not sending that in the request body. So we're getting a 400 status code here for a bad request. So how do we tell our Pydantic model that we don't need to send the ID in the post request? What we're going to do in VS Code is scroll up to our Pydantic model, and what we're going to do here is specify that that could be an integer or it could be null. And if it's not specified in the request, we're going to set it by default to that null value or the none value in Python. So let's try this again by saving the model. If we now go back to 𝗬𝗵𝗽 and we try and send this data again, this time we're getting back the correct response. And every time we send this, we should get back an incrementing ID because of that logic that we have in the post endpoint. And again, if we go back to the browser and we look at the actual list page, this time when we refresh this, we have all 8 bands in the list. Of course, there are duplicates of Black Sabbath here. We would handle that normally in our database to prevent that from being added. But of course this data is not persistent, we are just storing it in memory using this list that we have in our Litestar application. If we were to restart this server, for example, if I save this file again, it's going to restart the server, and when we go back to our page and refresh this page, we are back to only the 4 bands that were hard-coded into that list at the start. So that's all for this video. We have shown an overview of how to use the Litestar API framework in Python. We've seen how to define endpoints for GET and POST requests, and we've seen how to do that with functions, but also we've seen how to move those functions into a controller class. We've seen how to integrate Litestar with our Pydantic model classes that we can then use in our type hints for these endpoints, as you can see here. And there's a lot more you can do with Litestar. We've only scratched the surface here. If you're interested in more videos, please let me know in the comments. And if you'd like to see an example application, for example maybe a React and Litestar app or a Vue.js Litestar app, just let me know in the comments and we'll try and build one of those too. So thanks again for watching. If you've enjoyed this, please like and subscribe to the channel. And if you're enjoying this content, please consider buying a coffee for the channel too. And we'll see you in the next video.